Welcome to our comprehensive guide on SQL interview questions and answers. Whether you're a fresh graduate or an experienced professional, mastering SQL is crucial for landing your dream data job. In this video, we'll walk through 50 essential SQL interview questions, providing clear explanations and practical examples. From finding duplicate records to retrieving the second highest salary, we'll cover a wide range of topics that interviewers love to ask. Let's dive in and boost your confidence for your next SQL interview. One of the most common SQL interview questions is how to find duplicate records in a table. Interviewers want to see if you understand grouping and aggregation. Typically, you'll use the group by clause along with having to filter groups with more than one occurrence. For example, to find duplicate emails in an employee's table, you'd group by the email column and use having count, asterisk greater than 1. This technique is fundamental for data cleaning and ensuring data integrity in real-world databases. Let's look at a practical SQL query to find duplicate emails. Select email count asterisk as count from employees group by email having count asterisk 1. This groups all records by email and only shows those with more than one entry. Such queries are not only useful in interviews but also in real-world scenarios where you need to maintain unique records, like user registrations or contact lists. Sometimes you need to check for duplicates based on more than one column. For example, you might want to find records where both the name and email are repeated. In this case, you group by both columns. Select name email count asterisk as count from employees group by name, email having count asterisk 1. This approach is valuable when a single column isn't enough to define uniqueness, which is common in complex databases. Display the actual duplicate records, not just the counts. You can use a subquery. For example, select from employees where email in, select email from employees group by email having count, asterisk 1. This query returns all rows where the email appears more than once. It's a practical way to review and resolve duplicate data issues directly within your database. Another classic interview question is how to retrieve the second highest salary from an employee table. This tests your understanding of ordering, limiting, and sometimes handling duplicate values. Interviewers want to see if you can write efficient queries that work across different SQL dialects. Let's explore a common approach using distinct, order by, and limit. Get the second highest salary you can use. Select distinct salary from employee order by salary DESC limit 1 offset 1. This query first removes duplicate salaries, sorts them in descending order, and then skips the top salary to fetch the second highest. It's a concise and effective way to answer this common interview question, especially in MySQL and PostgreSQL. The offset clause is crucial when you want to skip a certain number of rows in your results set. In the context of finding the second highest salary, offset 1 skips the highest salary, allowing you to select the next one. This technique is widely used in pagination and ranking queries, making it a valuable tool in your SQL toolkit. What if multiple employees share the same highest salary? Using distinct ensures that each unique salary is considered only once. This way, even if there are ties, the query will still return the correct second highest salary. Handling such scenarios is important for robust SQL solutions, especially in real-world payroll or reporting systems. Another way to find the second highest salary is by using a subquery. For example, select max salary from employee where salary, select max salary from employee. This approach finds the maximum salary that is less than the highest, effectively giving you the second highest value. It's a great alternative when limit and offset aren't available. The group by clause is fundamental in SQL for aggregating data. It allows you to group rows that have the same values in specified columns, which is essential for tasks like counting duplicates or summarizing sales. Mastering group by is key to answering many interview questions and solving real-world data problems. A common point of confusion is the difference between having and where filters rows before grouping, while having filters groups after aggregation. For example, you use where to filter individual records and having to filter groups, such as those with more than one occurrence. Understanding this distinction is crucial for writing accurate SQL queries. Let's see having in action. Suppose you want to find all products sold more than once. Select producted count asterisk from sales group by producted having count asterisk 1. This filters the grouped results, showing only products with multiple sales. It's a practical use case that often appears in interviews and daily work. The distinct keyword is used to remove duplicate values from your results set. It's especially useful when you want to list unique entries, such as unique departments or cities. In interview scenarios, You might be asked to count unique values or display only distinct records, making this keyword a must-know. Order by is used to sort your query results in ascending or descending order. For example, you might order employees by salary or products by price. This clause is essential for ranking, pagination, and presenting data in a meaningful way. Interviewers often test your ability to sort and organize data efficiently. Limit and offset are powerful tools for controlling the number of rows returned by your query. Limit specifies how many rows to return, while offset skips a specified number of rows. Together, they're used for pagination, allowing you to display results page by page. This is a common requirement in web applications and interview questions. Subqueries are queries nested inside another query. They're used to perform operations that require multiple steps, such as filtering based on aggregated results or comparing values across tables. Mastering subqueries is essential for answering advanced SQL interview questions and building complex data solutions. Suppose you want to find employees who earn more than the average salary. You use a subquery to calculate the average, then filter the main query. Select from employee where salary, select AVG salary from employee. This demonstrates how subqueries can add power and flexibility to your SQL statements. Joins are used to combine rows from two or more tables based on related columns. The most common types are inner join, left join, right join, and full join. Understanding how to use joins is critical for working with normalized databases and answering multi-table interview questions. An inner join returns rows when there is a match in both tables. For example, to list employees and their departments, you'd write, select ename, D department from employee, E inner join department D on E, department ID equals DID. This is a foundational skill for any SQL developer. A left join returns all rows from the left table and matched rows from the right table. If there's no match, nulls are returned for columns from the right table. This is useful for finding records that may not have related entries in another table, such as employees without departments. Right join returns all rows from the right table and match rows from the left. Full join returns all rows when there is a match in either table. These joins are less common but important for comprehensive data analysis, especially when dealing with incomplete or optional relationships. Aggregate functions like count, sum, AVG, min, and max are used to perform calculations on sets of rows. They're essential for summarizing data, such as calculating total sales or average salaries. Interviewers often ask about these functions to test your ability to analyze and report data. The count function returns the number of rows that match a specified condition. For example, select count asterisk from employee where salary 50,000 counts all employees earning more than 50,000. It's a straightforward but powerful tool for data analysis. Sum adds up all values in a column while AVG calculates the average. For example, to find total sales, select sum amount from sales. To find average salary, select AVG salary from employee. These functions are vital for financial and business reporting. Min returns the smallest value in a column, while max returns the largest. For example, select min salary from employee find the lowest salary and select max salary finds the highest. These are useful for identifying outliers and setting benchmarks. Aliases allow you to rename columns or tables for readability. For example, select salary as employee salary from employee. Aliases make your queries easier to understand and are especially helpful in complex joins or when presenting results. The where clause filters records based on specified conditions. For example, select from employee where department equals sales. Where is used before grouping and is essential for narrowing down your data to relevant results. It allows you to specify multiple values in a where clause. For example, select from employee where department in sales, HR, not in exclude specified values. These operators are useful for filtering large datasets efficiently. Between is used for range filtering, such as select from employee where salary between 40,000 and 60,000. Like is used for pattern matching, such as select from employee where name like %. These operators add flexibility to your queries. Null represents missing or unknown values in SQL. You can check for null using is null or is not null. Handling nulls correctly is important for accurate data analysis and avoiding unexpected results in your queries. The case statement allows you to add conditional logic to your queries. For example, select name, case when salary 50,000 then, high else low end as salary level from employee. This is useful for categorizing data directly in your results. Union combines the results of two queries, removing duplicates. Union all includes all results, even duplicates. For example, select name from employee union select name from manager. These operators are useful for merging datasets. Indexes speed up data retrieval by allowing the database to find rows faster. They're especially important for large tables and frequently queried columns. Interviewers may ask how indexes work and when to use them for optimal performance. A primary key uniquely identifies each row in a table, while a foreign key links rows between tables. These constraints enforce data integrity and are fundamental concepts in relational databases. Expect questions about their differences and uses. Normalization is the process of organizing data to reduce redundancy and improve integrity. It involves dividing tables and defining relationships. Understanding normalization levels, like 1NF, 2NF, and 3NF, is important for designing efficient databases. Denormalization is the process of combining tables to improve read performance at the cost of some redundancy. It's used in reporting and analytics databases where speed is more important than strict normalization. Transactions are sequences of operations performed as a single unit. ACID stands for atomicity, consistency, isolation, and durability, properties that ensure reliable processing. Interviewers often ask about transactions to test your understanding of data integrity. A view is a virtual table based on the result of a query. Views simplify complex queries and enhance security by restricting access to specific data. Knowing how to create and use views is a valuable skill for both interviews and real-world projects. Stored procedures and functions are reusable SQL code blocks that perform specific tasks. They help automate repetitive operations and enforce business logic at the database level. Expect questions about their differences and use cases. Triggers are special procedures that automatically execute in response to certain events, such as inserts or updates. They're used for enforcing rules, auditing changes, or maintaining derived data. Understanding triggers is important for advanced SQL roles. SQL supports various data types, such as int, varchar, date, and boolean. Choosing the right data type ensures efficient storage and accurate data processing. Interviewers may ask about data types to test your understanding of database design. Constraints enforce rules on data in tables. Common constraints include not null, unique, check, and default. They help maintain data quality and prevent invalid entries, which is essential for robust database systems. SQL injection is a security vulnerability where attackers can manipulate queries by injecting malicious input. Preventing SQL injection involves using prepared statements and parameterized queries. Security is a critical topic in interviews, especially for roles involving sensitive data. We've covered 50 essential SQL interview questions and answers, ranging from basic queries to advanced concepts like transactions and security. Mastering these topics will give you a strong foundation for any SQL interview. Keep practicing, explore real-world datasets, and stay curious. Good luck on your journey to becoming an SQL expert.